Apa di anu ora?
Jadi institusi program Pascasarjana
yang Indonesia Raya.
Oh, berarti workshop.
tingkat nasional dan internasional pada tahun
Mas, dimut Prof.
sedangkan misi program Pascasarjana adalah satu menyelenggarakan pendidikan pascasarjana yang menghasilkan lulusan kompeten dan budi pekerti luhur untuk memenuhi pelayanan kesehatan tingkat nasional dan internasional. Kedua, menghasilkan penelitian kesehatan terapan dan berkontribusi nyata di dalam pembangunan kesehatan. Dan ketiga adalah menghasilkan karya kesehatan. Dan yang misi keempat adalah mengembangkan kemitraan dengan berbagai institusi pemerintah dan swasta tingkat nasional maupun internasional untuk meningkatkan kapasitas lembaga di dalam pengembangan ilmu pengetahuan dan teknologi.
Program studi yang ada di lingkungan program Pascasarjana Magister Terapan Kesehatan Poltekkes Kesehatan Kementerian Kesehatan Semarang. Program studi Magister Terapan Keperawatan, Magister Terapan Kebidanan, Magister Terapan Imaging Diagnostik, dan Magister Terapi Gigi dan Mulut. Kualitas pelaksanaan pendidikan dan pelayanan yang diberikan oleh program Pascasarjana Magister Terapan Kesehatan dibuktikan dengan didapatkannya akreditasi A untuk program studi Magister Terapis Gigi dan Mulut, serta akreditasi B untuk program studi Magister Terapan Keperawatan, Magister Terapan Kebidanan, dan Magister Imaging Diagnostik oleh Poltekkes. Tersedianya fasilitas berupa perpustakaan,
Siapa? Belum. Ini baru pengarasnya.
ruang pertemuan, ruang
sing di
laboratorium masing-masing program studi. Laboratorium kebidanan meliputi laboratorium laboratorium antartal,
yang
Kalau kamu invite gimana, Fit?
Meeting Zoom.
Gak bisa masuk tapi. Enak lagi ya. Walaupun laptop itu lemot, tapi jadi gak ingat ini. Oh, ini lagi banget kan. Iya, kalau saya yang di Ngome, itu itu. Nggak bisa gitu. Ya.
Febri.
Oke.
Good morning, ladies and gentlemen. Welcome to the program of Politeknik Kesehatan Kementerian Kesehatan Semarang. We proudly present it's been a great honor for me to be standing here and welcome each and every one of you in virtual lecture of visiting series with theme Problem Solving and Artificial Intelligence. Ladies and gentlemen, over the next few days, this meeting will provide you plenty of opportunities to discuss, share knowledge and insights, human cognition and artificial intelligence. Before we proceed the program today, we would like to express our sincere gratitude to Excellency, the Professor at the Department of Mechanical Systems Engineering, the Graduate School of Systems Design, Tokyo Metropolitan University, Japan, Professor Naoyuki Kubota, Master of Engineering. Welcome to Indonesia. The Honorable Director of Politeknik Kesehatan Kementerian Kesehatan Semarang, whom we respect, the chairman of the postgraduate program of Politeknik Kesehatan Kementerian Kesehatan Semarang, assistants of postgraduate programs, the chairpersons of the Health Applied Master's Program. As well, Excellency, distinguished guest delegates, ladies and gentlemen, honorable distinguished speaker, participants, delegates, ladies and gentlemen, let's listen to our national anthem, Indonesia Raya. Okay, for next, prayer by Mr. Mardiono, Master of Nursing, PhD. The time is yours.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam
Ladies
warahmatullahi
and gentlemen, before starting virtual guest lecture Series 1, let us pray as our religion. Those who are Muslim, pray with me, and those who are other believers, let's pray as your convenience. Allahumma salli ala Sayyidina Muhammad, Allahumma gfir lil mu'minina wal mu'minat, wal muslimina wal muslimat, al ahya'i wal amwat. Allahumma a'ini ala dzikrika wa syukrika wa husni ibadatik. Allahumma inni a'udzubika min an nusyrika bika syai'an na'lamu wa nastaghfiruka lima la na'lamu. Rabbana atina min ladunka rahmah wa hayyi lana min amrina rasyada. Rabbighfir warham wa anta khairur rahimin. Subhana rabbil izzati amma yasifun. Wassalamun alal mursalin walhamdulillahi rabbil alamin. Wassalamualaikum warahmatullahi wabarakatuh.
Okay, it is now my deep pleasure to introduce the chairman of postgraduate program to deliver welcome speech. Excellencies, our distinguished guests, ladies and gentlemen, without further ado, we would like to invite to the podium to deliver his welcoming speech. As chairman of the graduate program, Professor Dr. Suharyo Hadisaputro. Please give a warm applause. The time is yours. Introduce the chairman of postgraduate program to deliver welcome speech. Excellencies, our distinguished guests, ladies and gentlemen, without further ado, we would like to invite to the podium to deliver his welcoming speech as chairman of the graduate program, Professor Dr. Suharyo Hadisaputro. Please give a warm applause. My time is yours. The chairman of postgraduate program to deliver welcome speech. Excellencies, our distinguished.
Assalamualaikum warahmatullahi wabarakatuh. Ladies and gentlemen, our honorable guest, Professor Naoyuki Kubota, Director of Semarang Health Poltekkes, Mr. Marsum, our college lecturer and student and postgraduate program Master of Applied Health Science, Semarang Health Poltekkes. Welcome in postgraduate program Master of Applied Health Science, Semarang Health Poltekkes. Firstly, we would like to express appreciation and to convey our thanks for your virtual lecture about the problem solving and artificial intelligence in postgraduate program Master of Applied Health Science. I will introduce Professor Naoyuki. Professor Naoyuki Kubota, he is a professor at the Department of Mechanical System Engineering, the Graduate School of System Design, Tokyo Metropolitan University, Japan. He was a visiting professor at University of Portsmouth, UK, and was an invited visiting professor at Seoul National University. His current interests are in the field of co-involuntary computing, basic computing, topological mapping, cognitive robotic, social robotic, and informationally structured phase. Professor Naoyuki in diagnostic study program and dentist study program. Our program and produce Master of Applied Health Science based on local culture and to be able to competition in national and international. Competency of the graduate innovator, manager, counselor, and applied researchers. Ladies and gentlemen, now Professor Naoyuki will give lecture virtual and important topic in problem solving and artificial intelligence. The topic is very important for us, our lecturer and our student, to develop of current role of artificial intelligence and what the application for healthcare mainly artificial intelligence. Again, I would like to thank for Professor Naoyuki Kubota. We hope that the
Sudah belum Satrio? Ini masih di HP nih, gambarmu masih kecil loh. Hah?
Ini khususnya siapa? Anunya siapa? Kumi. Tapi krungu. Itu ngomong dia.
Oke, Prof, kami bisa mendengar, Prof, monggo, Prof. Sakit dilanjutkan.
Loh.
Ini
Participant virtual lecture and today consists of lecturer, student and staff in postgraduate program, Master Applied Health Science Semarang at Poltekkes. I hope that lecture will give all student and lecturer better knowledge, mainly artificial intelligence. Again, I would like to thank for Professor Naoyuki Kubota. We hope that the cooperation continue between Health Polytechnic Semarang and Tokyo Metropolitan University, Japan. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
And afterward, we would like to request the Director of Politeknik Kesehatan Kementerian Kesehatan Semarang to give a speech and also officially open the virtual lecture of Visiting Professor Series 2020. Ladies and gentlemen, this is the Director of Politeknik Kesehatan Kementerian Kesehatan Semarang, Mr. Marsum BE, SPD, MHP. Please give a warm applause. The time is yours.
Mohon izin Bapak Direktur, suaranya masih mute.
Okay?
Yeah, we can hear you.
Yeah.
Thank you very much. Sebelum hujan, sediakan payung. Ketika hujan, suka melamun. Melihat semangat partisipan yang bergabung, kusapa kalian dengan salam santun. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good morning, everyone.
Good morning, Mr. Director.
Morning.
Selamat pagi, Prof Naoyuki Kubota. Ohayo gozaimasu.
Selamat pagi.
Selamat pagi, terima kasih. Salam sehat. Sehat Indonesia. Bersyukur. His Excellency, a speaker and experts from Tokyo Metropolitan University, Professor Naoyuki Kubota, the Honorable Head of the Postgraduate Program, Profesor Dr. Suharyo Hadisaputro, SPDPD KPTI, the first and the second assistant of the postgraduate program, Mr. Dr. Ariswondo, and Miss Dr. Meliana Nurul Widyawati, SSIT Kemenkes, and our distinguished guest, special guest from Poltekkes, Miss Nia Kurnianingsih, Head of Study Program, lecturers, students, and all of webinar participants. First of all, let us praise and thank to Almighty Allah for the abundance of grace and the joy of all us can still gather in this place without any barrier at all and heal in health condition. On this occasion, I would like to congratulate to Progressive Program Poltekkes Kemenkes Semarang for organizing virtual lecture series with the theme Human Condition and Artificial Intelligence, which be presented by a Professor, Doctor of Engineering, Naoyuki Kubota, Bachelor of Science, Master of Engineering from Tokyo Metropolitan University, Japan. I would like to say, welcome Prof Naoyuki to Poltekkes Kemenkes Semarang, and thank you very much for your coming virtually. Semarang, yukoso domo arigato gozaimasu.
Terima kasih.
Ladies and gentlemen, especially Prof Now, I will explain briefly the profile of our institution. Poltekkes Kemenkes Semarang is an health education professional institution under the Ministry of Health of Republik Indonesia and the largest Poltekkes in Indonesia. We have 8 departments and 1 postgraduate program. The majors are nursing, midwifery, nutrition, radiodiagnostic and radiotherapy, dental nursing, environmental health, medical laboratory, medical records, and health information. It is an honor for us that Prof Now is pleased to conduct a visiting professor at the Poltekkes Kemenkes Semarang. Theory about human cognition and artificial intelligence is a new thing in Poltekkes Kemenkes Semarang. I hope the implementation of this event will be the beginning of collaboration in the field of health education. The knowledge that will be delivered by Professor Now can be applied later at Poltekkes Kemenkes Semarang, so we can more advance and more innovating. I hope in this occasion, Prof Now can talk not only the topics, but you can talk anything about Japan, about everything related to Japan, because you know that Japan from Indonesia is very popular, very familiar. When I child, I have a novel about Doraemon, Dora Explorer, Nobita, Oisin, and so many about Japan. So I hope the participant, you can explore what do you want to know about Japan with Professor Naoyuki Kubota. Last but not least, I wish you a joyful webinar and have a good impression with this event. Thank you very much. Domo arigato gozaimasu. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Warahmatullahi wabarakatuh.
Thank you for the opening speech from Director of Politeknik Kesehatan Kementerian Kesehatan Semarang. And now, Excellencies, ladies and gentlemen, now we come to our main program, plenary session, who will be led by our moderator, Dr. Meliana Nurul Widiawati, SSIT Kemenkes. The time is yours.
Okay, thank you, Mrs. Novita. Assalamualaikum warahmatullahi wabarakatuh.
Salam.
Good morning, ladies and gentlemen. Welcome to this virtual lecture series entitled Problem Solving and Artificial Intelligence by Professor Naoyuki Kubota. He is the Director of Community-Centric System Research Center of Tokyo Metropolitan University, Japan. My name is Meliana and I will be serving as your moderator today. First of all, I would like to thank to Mr. Marsum as the Director of Poltekkes Kemenkes Semarang and Professor Suharyo Hadisaputro as the Head of Postgraduate Program Poltekkes Kemenkes Semarang and all audiences. Thank you for joining this virtual lecture series. Before we start the presentation, I would like to read the sequence of this virtual lecture. This virtual lecture is divided into 3 sessions. The first is presentation, the second is discussion, and the last is conclusions. The following is the brief curriculum vitae of Professor now. Mr. Brian, can you share his CV? Thank you. From the slide, as you can see from the slide, details of his educations and work experiences, and then his current interests are in the fields of co-evolutionary computing, fuzzy computing, topological mapping, cognitive robotics, social robotics, and informational structure space. He has published more than 500 referred journal and conference papers in the above research fields. He received the Best Paper Award of IEEE Icon 96, the Best Paper Award of IEEE Sierra 97, and so on. He was an associate editor of the IEEE Transactions on Fuzzy Systems from 1999 to 2010. The IEEE CIS Intelligent System Applications Technical Committee, Robotic Task Force Chair from 2007 to 2014, IEEE Systems Man and Cybernetic Society, Japan Chapter Chair since 2018, and others. The study on cognitions, intelligence, consciousness, and self has a long history. Cognitions is defined as the mental process of knowing, including aspects such as awareness, perception, reasoning, and judgment, and intelligence is defined as the ability to acquire, understand, and use knowledge according to American Heritage Dictionary. Cognitions and intelligence are interrelated each other, and these two are discussed from the viewpoints of processing and ability. Therefore, we have to consider both cognitions and intelligence simultaneously to discuss artificial intelligence. In this talk, first, we consider the human ability of problem solving and discuss how to realize artificial intelligence. And the next, we consider visual perception and explain clustering and classification problems. For your information here, this event held as a beginning of Memorandum of Understanding initiations from the letter of intent between Poltekkes Kemenkes Semarang and Technology TMU, Tokyo Metropolitan University, we signed last year. Our students have a lot of research about AI for health problem solving. So they need to know about AI from basic. By this virtual learning, hopefully our students get a new idea to start their thesis research. On the other hand, AI and robotic technology that you developed are extremely needed in this pandemic era for the good sake of human being. On the next chance, we hope that Professor Naoyuki would like to be a keynote speaker on our international seminar to discuss more about AI and robotic technology on the healthcare practice to prevent COVID-19 transmissions. And now, I would like to invite Professor Naoyuki to present his matter about problem solving and artificial intelligence. So to Professor Nao, time is yours.
Terima kasih. So, okay. So may I share the screen?
Okay. Okay, we can see your presentations.
Okay, just a moment. Okay. So before that, so I would like to say one thing. So I use chat here. Therefore, so please activate the chat on the Zoom. Okay. So first, so just a moment.
Okay.
I just sent the URL link of the movie in the chat. Please check it. So if you want to watch the movie, so I presented here, so you can visit to this URL link. Okay.
Okay, I see. Yes, we already get your Dropbox here.
Terima kasih, Mariana. Selamat pagi. Kenalkan, nama saya Naoyuki Kubota, Tokyo Metropolitan University, Japan. So, terima kasih. Okay, that's all. So let me start my talk. So it is my great honor to have a chance to give a talk to everybody today here. I'm very happy to be here, but so still in Japan. So anyway, so let me start my talk. So this lecture is composed of two lectures. The first one is problem solving and artificial intelligence. So maybe so you can find so much better slide on the introduction to AI at the web page. So in my talk, I don't teach artificial intelligence. So let's consider what is intelligence. So what is artificial intelligence? This is the aim of my talk today, okay? So therefore, if you are familiar with artificial intelligence, so you don't need to listen to my talk, but so I will give many questions. So therefore, so if you are interested in the definition of intelligence or cognition, so you please consider such a definition. Anyway, so let's use our brain to consider intelligence. This is a starting point to discuss AI. So I'm a robotics researcher, therefore, so I just show some previous works here. So please enjoy the movie. So at the URL link of the Dropbox. So I'm sorry, but I want to use a large screen. Therefore, so I watched my screen here. Therefore, so my angle to me is different. Maybe so you don't want to watch my face. Therefore, please focus on my slide only. Okay. So please consider this puzzle in the beginning. Do you know single stroke drawing? So if you want to reply to my question, so please write something at the chat in the Zoom, okay? So this is the first one. So single stroke drawing 6-line segment. So this is very easy, I think. So can you solve this problem? Do you know?
Pardon?
Yeah. So however, so this is a famous problem on single stroke drawing. So we cannot solve this one. Okay. So how about this one? 4-line segment. Here we don't show any line segment. Okay. So can you connect 9 point with 4-line segment? Can you? If you can, so please reply to the chat. Yes. Okay. So if you don't know this problem, please consider the solution of this quiz in my talk. Anyway, so I will consider what is intelligence, what intelligent is. So by using this problem, okay. So now, I go back to my talk. So first of all, I would like to say special thanks to my supervisors and great teachers for me. So maybe you know Professor Toshio Fukuda. So he is a current president of IEEE. So he gave me so many ideas in this research field. Actually, he is a robotics researcher, but he is very clever about artificial intelligence and also computational intelligence. So he started the research on fuzzy system, fuzzy theory in 1970s. So he is one of the pioneers on fuzzy systems in Japan. So in my laboratory, almost 10 PhD students graduated from my laboratory. So these are my friends and colleagues. So this shows my laboratory members. So I play basketball a little. So when I go to Indonesia, I want to play basketball with you. Please practice before that, okay? So I look forward to playing basketball with you. Thank you. So I explain something about Indonesia. So 6 Indonesian students joined to my laboratory until now. So one of them is Dr. Indra. So do you know him? So he is currently the Vice Director for Academic Affairs of PENS. He is more famous than me. So this is the advantage of child. Okay. So now, for Indonesian people, belong to my laboratory. So Mr. Azhar, he is a current PhD candidate. He will get a PhD this year. So he already published 4 IEEE transaction papers. He is very clever. So actually, thanks to Indonesian students, my research become more advanced now. Thank you very much. Terima kasih. So let me introduce something about my university. So there are several international research centers in my university. So I joined 2 research institute in TMU. So one is Service Robot Incubation Hub. So we call Sabot Inc. So in this research group, we develop advanced robot to realize a high quality of service to people. So the other one is Community-Centric System Research Center. Now, after 5 years, the name of this research center is changed, Research Core now. So here, in this these research centers, we focus on systems thinking and design thinking. So design thinking is very popular recently, but we have discussed how to design until now, from many different viewpoints. So one of them is system thinking. So the approach on system thinking was very popular in 20th centuries. So however, this idea this thinking, this thinking approach is very important to realize design thinking. So partially, so system thinking is one part of design thinking, but so system thinking approach is very important to discuss the problem solving. So today, so I talk about something about system thinking by to solve a problem. So please don't forget, so 9-point problem. So one stroke drawing problem, okay? So now, so I explain several robots so developed until now, so in my laboratory. So in my research, so we have developed very different types of robots, so like this and like this. So and also, so recently we focus on the care to children or the rehabilitation support for disabilities people. So like this. And also we are developing some guide robot at airport or a shopping mall. So this is one example of smart electronic cars. So like this. So actually, not only the development of robot service robot, we have proposed many different types of computational intelligence, so methodology. So this is one example. So next week, I explain the detail of clustering method. So here, this is a surface model of two different objects. So in my methodology, so we can build this kind of surface modeling method by using topological mapping. So I will explain the detail about this one. So and also, so we have developed this kind of animal types of robot. This is one example. So this robot is climbing up in the ladder like this. This is a very difficult task. So this robot is developed by Indonesian student, so Mr. Azhar. So he is very clever and very nice student. So now, so I move to today's topic. So actually, so your university so deal with health problem and also medical science. Therefore, so I focus on some example about its related research topics. So we have proposed the concept of computational systems care based on computational approach and systems approach. So computational approach means have to use computational method and computational intelligence. I will explain something about computational intelligence later. The other one is systems approach. So this is the most important to discuss the phenomena of complex system or complicated problem. So for example, according to the systems approach, so we can discuss the care, so like this, from measurement, monitoring, feature extraction, recommendation, daily care, and anomaly detection. Actually, so we can so clarify the hierarchy of the target functions, and also so we can so discuss the relationship from sensing to action here, so service or control or something. So some service to the elderly care or something. So in this way, so we try to construct a computational systems care approach, so like this. So I show some example. So 10 years ago, almost 10 years ago, we started the development of robot partners for elderly care. So actually, owing to the facial recognition and voice recognition, this robot is responding to their communication. So like this. Actually, so the number of elderly people in Japan is increasing so rapidly. This is a big problem. So especially in Tokyo area, this problem is very serious issue. Therefore, we have to realize this kind of elderly care system by using robot technology and so sensing technology, and also, of course, so artificial intelligence. This is another example. So this person, so maybe the age of almost 100 years old. So he wants to sing a song, the same song twice or 3 times a day. At that time, if so he sing a song alone, he feels so sad. Therefore, so this robot sing a song together with elderly people. This is another example. So after that, so we developed many different functions for elderly care. So anyway, so this is a starting point to discuss the elderly care in my university, in my laboratory. Okay, so this is a measurement system, so smart health. So I just show some example. So according to the movement of this person, so we monitor. We can extract so life log by using human detection, human recognition, behavioral recognition, and others. So like this. So this is another example. So by using so current deep learning technology, so we can find easily this kind of fall detection. So this is another example. So in this example, so we this system can find gaze direction like this. So actually, it is very so it takes high computational cost. So extract every object in the room. So on the other hand, in this system, according to the gaze direction, so this means we can find so attentional range of this person, and then we just extract the object that this person pays attention to. So like this. And also after, so this person pick up some object, so we can learn. So this system can learn the behavior transition. So by using life log, this kind of life log, so this system can predict so next behavior. So in this way, if this person take a different behavior from the predictive behaviors, so we may consider this kind of action as so anomaly. So in this way, so we can realize anomaly detection by using this system. Of course, so robot is here. Here is robot. So this robot can communicate to the person. So this is a current result of elderly care system. So next, so I explain another example, application example of computational approach and systems approach. So we have proposed the concept of computational systems rehabilitation. So like this. So from measurement, monitoring, feature extraction, this is very similar. But so we try to use this kind of idea to rehabilitation planning support and also home rehabilitation. So in Japan, this is another problem. So in case of elderly care or sometimes dementia people, so we have to care such a dementia people so in house. Of course, so just only monitoring is easy, but if possible, we try to realize the rehabilitation. It is very difficult, but so we may stop the progress of dementia. So if we use artificial intelligence and robot partner, so this is the aim of this research. So almost 10 years ago, we started the research of rehabilitation support for a patient with higher brain dysfunction. At that time, we developed many smart device applications. So like this. So recently, so 3 or 4 years ago, we started the research on the rehabilitation to children with developmental disability. So in the beginning, I show some movies. Okay, so like this. Okay, so this is another example. So recently we found the relationship of gaze attention. So attention and its corresponding behavior. So therefore, so after the higher brain dysfunction, so we try to extract the relationship attention and its corresponding behaviors. We are developing this kind of driving simulator. So this is one example. So actually, so it is very difficult for the patient to change the attention dynamically. So by using this system, so we can extract what the patient focus on and what the patient does not pay attention area. So and then so we can make a rehabilitation program by using this. Okay, so this is a current situation of my research to rehabilitation area. So now, so I move to today's topic. So today, so I explain how to solve a problem by using one-stroke drawing. So this is the main target. Okay. So first, so I show the history. Maybe so you can find so this kind of story at the web page. So please refer to the web page if you are interested in the story history. Okay. So I show one interesting movie only. So you can access this so YouTube URL. So I like him. So self-reach. So his insight is very interesting.
There's no sound here, Professor.
Huh?
No sounds here.
Sound is so you cannot listen to sound of this movie.
No, we can't.
Okay, no problem. Okay, no problem. Okay, so anyway, so this is my first question. So what is thinking? Okay, sorry. Just a moment. Oh, so many comments to the chat. Okay, so I will check it later. Okay, so anyway, so what is the definition of artificial intelligence? So I searched the definition at several dictionary here. So anyway, so maybe you can see, for example, here. So normally, so what is normal? So intelligence. Okay. So here in this definition, so Cambridge Dictionary. So in this dictionary, this definition focus on human mind and also problem solving. So in Encyclopedia Britannica, so this dictionary so refer to the robot to define the artificial intelligence. So each dictionary has different definition. So can you define AI? Maybe so it's difficult. However, so after my talk, so please consider the definition of AI. Okay, so if you consider the definition of AI, so it is my great pleasure to give a talk here. Okay, so now, so I just explained something about intelligence. So actually, so I like so this idea. So in 1994, more than 20 years ago, so Bezdek, so he is very famous researcher in computational intelligence, especially fuzzy theory. So he defined so ABC of intelligence. So this is so AI, of course, AI, BI, CI. So the first one is biological intelligence. So our human brain, or so animal's brain. So we can discuss the animal's brain or biological intelligence from the viewpoint of cell organization. Maybe you are familiar with cell organizing system, so in medical area or human science. So here, so they discuss the importance of structure or order. So our brain is really complicated, but so organized well. I don't know why. Actually, so this is amazing. So everybody have so similar brain structure. So this is a power of so genetics. Yeah. So why? So can our living creature can develop such kind of order? So this is a one important issue in the research area of biological intelligence. However, in order to discuss intelligence, this is a point. So our brain can be analyzed by using physics, so electricity transition and also chemical interaction. But we cannot explain the intelligence by using chemical interaction. So what is intelligence? In order to immerse so intelligence, we have to find this clause, so alpha. So physics and also chemistry, so these are very important. But so they try to disclose what alpha is in intelligence. So this is the aim of biological intelligence. So this is so artificial intelligence definition. So actually, so artificial intelligence so can be discussed from the viewpoint of top-down external description. In the original AI, we try to realize human symbolic processing ability. So they believe human only can deal with high level of symbolic processing. Therefore, they originally, so they try to discuss the importance of symbolic processing. So after that, at the time, they are also discussing discussing about the numerical processing of human brain. So we can analyze human brain. So in this research, so we try to discuss the human intelligence from the viewpoint from the computational point of view. So this is a research on computational intelligence. Please see the relationship. So in case of artificial intelligence, so we can discuss AI intelligence from the top-down approach. On the other hand, so we try to discuss the intelligence from the bottom up. So internal description. So what is running? So what is cell organization or something? Okay. So this is a comparison. So here. So in the beginning, I say, so we should use systems thinking. So by using systems thinking, we can clarify the relationship, hierarchy, or comparison like this. Okay. So in this way, so we can clarify, have to discuss intelligence like this. So ABCs of intelligence. So this is very interesting to me. So when I was a PhD student, I learned this keyword from the keynote speech by Bezdek. So I was so inspired from his talk. So after that, so maybe so 21st century, so 2003, so we had a chance to discuss A to Z of intelligence. So this is just my opinion. Yeah. So okay. So if I have a chance, I want to have a workshop with you to discuss A to Z of intelligence like this. Okay, I will skip the detail. So now, so let's use our brain together. This is very famous example of image processing. So and also artificial intelligence. So actually, this is a typical image processing task. So if we obtain this kind of image, and then we can extract the features like this. Okay. So here, in case of characteristic level, character recognition level, so we can recognize so this character as A or H. Which do you think? So if you can use Zoom, please write. So which? Which is? So do you think? So this is A or H? Or nobody write? Okay, so here, please check. In context level, okay? So what is this? A or H? Maybe so H, maybe H. So here, A. So Selfridge, so I introduced him in the movie. So Selfridge, so already discussed this kind of problem in 1955. So he is super clever. Okay, so the next one is here. So for this, A or H, which? So please consider. Maybe so we can find full name here. Cylinder head temperature. Oh, this is H, not A. Do you think? So current artificial intelligence can recognize this abbreviation? Of course. So if we teach, so have to do this, so the AI can do it. But so we have many different types of abbreviation. Sometimes so cylinder head temperature, so differently in the screen, like in the posture or something. Okay, so this is very difficult task, but human can do it. So our brain is very clever, very intelligent. Okay, now, so Professor Fukushima, he is maybe so 80 years old now. He is still very nice researcher. He write a paper in his house. So he proposed a neocognitoron. Neocognitoron is one of pioneer works on deep learning. So he proposed the concept or methodology of neocognitoron in 1980. So he still continues the research on neocognitoron. So he showed me so this example. Okay. So what this? Can you say what this? So actually, so some kind of shape. I don't know. Look at this one. What this? A. Amazing. So actually, so in the right figure, so we just so hide so some part of this character. But when we clarify, so which part is hidden, so we can recognize this character. This is human ability. So unbelievable. The next one is here, this one. Okay, so this is very easy. What this? What is this character? Can you see? Okay. This one. R. Okay. So do you have some other reply? Some other answer? Here. B. So this is our human cognitive ability. So I like this kind of questions and problems. Actually, so in order to clarify our human intelligence, so we try to discuss why from this kind of problems. And then so we can develop new method. Okay, so I will give you 2 minutes. So please consider what is intelligence. So please write so your idea in the chat. So 2 minutes. So please write your idea to the chat on the Zoom. please write. So this is a lecture. Therefore, so please consider and write your comment on the chat. Maybe so almost 100 students join to this Zoom meeting. So please write down. Okay, so if you don't want to disclose so your idea, please send only me. So private message, okay? I don't show so your answer to your teacher. What is sorry. So now mute. Okay. Okay, almost 2 minutes passed. So what is intelligence? So please write down your idea on the chat. Nobody write. Oh, good. Oh, one more, please. One more, please. No more? Okay. Oh.
Okay.
Good, good.
Yeah. Yes.
Yeah. So actually, so for example, according to American heritage, so the ability to acquire, understand, and use knowledge. Oh, this is very standard. Okay. So in case of so this one, the ability to learn or understand or to deal with new or trying situations. Or here, in very interesting, a situation. Deal with new situation. So actually, so this is important. So if we don't know new knowledge at that time, we have to solve a new problem, such kind of new problem. Okay. So this is another one. So individuals differ from one another in their ability to understand complex ideas to adapt effectivity. So anyway, here, this is also important to learn from experience. Okay. So anyway, so you can see the definition is very different in many dictionaries. So what is intelligence? Yeah. So this is a point. So anyway, so today, so I follow American heritage. Okay. So I explained. So what is intelligence? The ability to acquire, understand, and use knowledge. So anyway, so in the previous discussion, so our cognition is very important to discuss intelligence. So therefore, so I found the definition of the cognition in American heritage like this: the mental process of knowing. So including aspects such as awareness, perception, reasoning, and judgment. Here we can find the meaning. We can find the term of perception. What is perception? The process of perceiving something. So here, something is important. Something with a sense. So later, so we will discuss perceiving something. Okay. The last one. Okay. So sensing, to become aware. So it is also difficult to discuss what awareness is. So what is awareness? This is also difficult, but so we focus on these keywords: cognition, perception, and sensing. Okay, so first, let's consider aware. So I go back to the initial question. So do you remember? So single stroke drawing. So can you connect? So 9 point with four line segment? Did you? Do you know the solution? Actually, so this quiz is very popular in design thinking to consider the solution. However, so we just use this problem as a mathematics quiz. Okay. Here, this is one example. So we can connect 8 points, but we still have one more point here. So it is very difficult to solve. Why? So actually, so we are aware of this kind of box as a range of attention when we solve the problem. So actually, so when we solve a problem, we have to set some solution space or search space like this. So if we focus on this kind of box, we cannot solve this problem. Okay, so this is the answer. Maybe so some of you know so this answer. Therefore, you are not so amazing. But so when I was a child, at the time, oh, you teach me. you cheat me. Oh, so why? So can we use this point as a bending point? Oh, okay. So here, what did I do? What did we do? So we can extend or reduce the range of attention to solve a problem. This is human cognitive ability. So if we extend our attention like this, we may solve a problem. Can computer do such a thing? So artificial intelligence can do it. So this is a point. So now, so therefore, so I want to show this example. So human cognitive ability is very nice. Okay, so now, so we consider so how to solve so this problem by using computer. So if so we use 9 discrete points as a search point, we cannot solve a problem. So no solution. No solution. Okay, no solution. So and then so we can extend the search space like this. So if we use a set of real numbers, of course, so we may solve this problem, but difficult to solve. Okay, so and then we may use a set of integers. We may solve this problem, but still difficult to solve. So have to use the solution space, have to design. So anyway, so this is a point. In order to use artificial intelligence or search algorithm, so we should reduce the search space. So otherwise, we need much more time. So this is 9 points only, but if the number of points is increasing so much, so it takes much time to solve. So therefore, so we should find some method how to reduce the search space. For example, this one. So in order to solve this problem by computer, so we can use a set of lines connecting 2 or more points, so like this. So by using this idea, so we can solve this problem in this search space. So 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12. So 12 lines. So this is a candidate for to solve this problem. And then, so these kind of line segments are also candidate. So here, the number of solution is countable. So therefore, we may choose one by one. However, so we don't do such a thing. Anyway, so in order to solve a problem, we try to reduce such space like this. This is our human cognitive ability. So actually, the number of candidate lines, the combination of 9, 2, so like this, finite space. So here, so what did we do? So originally, so we try to connect 9 points, but So in this example, so in this solution space, we just, okay, we convert this problem to a new problem like this to choose 4 line segment, okay? So in this way, so we can reduce the search space. So who is intelligent? Actually, of course, so we can write this kind of method by using programming language. But so who is intelligent? Who is clever? So AI can solve this kind of problem, but human is clever. So therefore, so we have to discuss human cognitive ability. Okay. Yeah. So here, this is a point. So what is sensing? I explained the meaning of sensing is to become aware of. So in the beginning, we have to conduct data collection. So this means we have to design the search space, efficient search space to solve a problem. If we fail, if we fail to design such space, actually, so we may not solve a problem. And also, we need much more time to solve a problem. So here, what should you perceive to solve a problem? So actually, so in the beginning, so we cannot find some suitable search space. So this is a point. So we have to design the search space beforehand, but we cannot understand what to perceive until we solve the problem. So after we solve a problem, so we can design the search space. So this is a important feature of our brain, our intelligence. Actually, so therefore it is very difficult to solve the problem. This is a problem. So anyway, so until we solve the problem, we cannot understand what to perceive. So after solving a problem, we know everything. Okay, so I just show some definition. So here, so we can write an algorithm. So in order to use artificial intelligence, we have to consider the definition of algorithm. So these two are the typical definition, but this definition is not enough. Why? So actually, so if, for example, if we use a set of real numbers, so we may not stop the calculation. So we have to stop the procedure. Therefore, so we have to write an algorithm to solve a problem. So in finite time or finite processes. This is the most important. So, okay. Yeah, so I skip. So now, so how to solve? So we will move to the next step. So here, so we change the problem to choose 4 line segments. So like this. For example, if you choose 3 line segments, so like this, in this stage, so here is a current point. Okay, here we have 3 options. So this line segment, this line segment, this line segment. So if we choose this line segment, so we cannot solve a problem. The next one is here, so we can solve this problem. So if we choose this line segment, we cannot solve a problem. So therefore, so we have to consider, so have to search and have to design the search space simultaneously. Okay. So here, another problem. So actually, so in this situation, actually, so one step is different. So in the final stage, we choose this line segment, or this line segment, but its corresponding result are different. So like this. So have to evaluate the quality of this solution. So here, the aim of this problem is to connect 9 points Therefore, the difference, so we can calculate the difference is 2 here. Yeah, 7 point connected here, 2 point different. However, so from the different viewpoint, we may consider so the difference is like this, one line segment. Okay, so this one. So here we connected 8 points, therefore 1 point different. So on the other hand, here, so this line, if we change, actually, so it is a little difficult. I just show. Okay, so if we change, yes. Okay, sorry. Okay, so one is different. Okay, so if we change the two step is required, but so one line segment is different. So which do you choose as an evaluation factor? We have to consider the difference to evaluate the quality of solution. Okay, so this one and this one, so similar, near, similar or near. So here, so we have to consider the definition of difference. So these two, so have to evaluate the difference, so between two solutions. So, and also I showed some example in the beginning, so about character recognition. So we may use the angle or so vector like this, and then so we can calculate the difference here. So, and also if we focus on this feature, so here is open, here is closed open, so which is near? Actually, so our human cognitive ability can evaluate something. However, so we don't use explicitly such kind of features, knowledge to evaluate this one. So, however, so in order to implement so pattern recognition or something, we have to clarify the difference. So here, so in order to discuss the difference, we can use the concept of norm. So this is very fundamental mathematics so theory. Therefore, so we may skip. So the norm is so like this. Okay, so we may skip, but so this is very important here. So I explain something. So do you know norm? The concept of norm. Okay, so L, for example, L1 norm. So L means length. Okay, so L1 norm here. So this is a sum of absolute value. So like this. So this is very familiar with you. So L2 norm. Okay, so this is similar with so Euclid distance. I will explain that. So here, so if the norm is 1, so we can draw so like this from the 0 point origin. So here, okay. On the other hand, in case of L2 norm, so we can write a circle that the norm is the same from the origin. Okay. So how about this? In case of P, so LP norm. So here, so piece root of piece power of so each element, so like this. So if so P is very large, so at the time, for example, we assume so xk is a maximum absolute value. So we can approximately define the piece LP norm is defined as xk. So xk is a maximum absolute value. So in case of infinity, okay, P is infinity. So we can calculate the length is a maximum value of element. So like this. So here, so if the norm is 1 here, so we can write like this. Okay. So please consider this one. So can you see? Very small. So minus infinity. P is minus infinity at that time. So how can you define the norm? Oh, very silent, of course. So this is virtual lecture. So okay, no problem. So in case of infinity, so we can define like this. So maximize. So in case of minus infinity, so we can define like this. So minimize. Okay. So anyway, so in case of the learning approach in artificial intelligence, so we may use this kind of norm. So now, so I move to the distance. So distance is an extension of the norm. So here, so I already explained so like this. So here, so this is a Manhattan. Actually, so in case of L1 norm, we call so Manhattan distance. So and also here, in case of L2 norm, so we can say so Euclidean distance like this. Okay. So the last one. So in case of infinity, P is infinity. At the time we say so Chebyshev distance like this. So please draw the distance. Okay. So in case of Euclidean distance, so this is a point X and Y here. So it's easy. It's easy to draw. Okay. So this is a distance, Euclidean distance. So how about this? In case of Manhattan distance. In case of Manhattan distance, how to draw? Okay, this one. Of course, so we can write this one and this one. Okay, so this is Manhattan distance. So how about last one? So Chebyshev distance. Okay, in case of Chebyshev distance, so we try to choose the maximum element. So here, okay. Actually, in case of so this definition, the length is decreasing from Manhattan distance, Euclidean distance towards Chebyshev distance like this. So if we focus on the learning, so what should we focus on? So maximum error or maximum cost or something? On the other hand, so we fairly evaluate each element, so we may use Manhattan distance. Okay. So anyway, so next week I will explain so how to use this kind of distance concept. Okay. So do you have some questions? Actually, so I already used so much time. Therefore, so I cannot have some question time now. Okay, so I received several questions to the chat. So I will reply later.
Yeah.
Okay.
I send you questions.
Yes.
Okay.
Okay, now. Okay, so I move to the next topic. Actually, so I will explain clustering and classification in detail at the next week's seminar. But so please consider the essence of clustering and classification. I will use this example. Okay. So maybe so you can find several dots. So in the right hand, you can find some different shapes and different colors like this. Okay. So here, so how many groups can you divide the data into? How many? How can you divide?
3.
3, yes. 3. Okay. So here, so can you divide the data into circles, triangles, and rows and this? Can you?
Yeah.
Yeah, easy. Okay. So here, so how can you divide the data into circles, triangles, and lozenges? How? Actually, so we try to find several differences by observing the features. Okay, so now, so I explain. So this problem, so how many groups can you divide the data into? So this kind of problem is called clustering. On the other hand, okay, so here, as I mentioned before, something is important. So we may perceive something from data set. So actually, so according to the perceived something, so we can conduct clustering. Here, we don't tell you how to divide. Okay, so this is the problem of clustering. So here, we don't tell you how to divide. Therefore, so we don't have any teacher. Therefore, so this kind of approach is called unsupervised learning. Okay. On the other hand, so this method, so we call classification. Here, we already know the shape of the meaning of circles, triangles, so lozenges. So the meaning of circle is this. So no edge, no node. Okay. So in case of triangles, already you know the meaning. So therefore, so according to your knowledge, so you try to know this kind of data distribution. So this is we may say this kind of process cognition. In this example, we tell you how to divide. So there is a teacher. Therefore, so we say this kind of approach, supervised learning. Okay. So I already explained how to design the search space here. So actually, so something. So we try to perceive something here. So feature extraction is the most important. So according to the feature extraction, so we can conduct clustering. Okay. So here is classification. So now, so next quiz. Draw two lines to divide the following point. How to divide? Can you? Okay, this is a little confusing, but maybe draw two lines. Yeah, constraint is two lines here. Maybe so we try to divide the following point like this. Do you agree with this segmentation? So please write something if you don't agree. Oh, I have a different idea to divide these points. So please write down at the chat. Okay, the next one, please. Okay, sorry. Here. Yeah. If you are aware of the closeness of data distribution, local data distribution. Okay. So therefore, so you can draw these lines. Here, what feature do you use? Okay. So this is a point. Yeah. So so here, so you just use the closeness of local data distribution, and then so you can draw these two lines like this. So how about this? Draw one line, just only one line. So draw one line to divide the following point. Yeah, this is a difficult task.
Draw diagonally to separate different color.
Yeah. Okay. Here. Yeah. In my case, I try to draw one line like this. Do you agree? Do you agree? Okay, here. So can you call this segmentation clustering? Is this clustering?
I think yes.
Oh, good. You are clever. So you are aware of both difference, the difference of color and the closeness of data distribution. But so you just focus on the color distribution only and select it. So you selected color distribution. Okay, so according to the feature extraction, which feature should we choose? So this is a point. So according to the selection method, feature selection method, we may obtain different clustering pattern like this. Yeah. So this is the most important. So you are not asked to classify the data according to color. Therefore, so we can call this segmentation clustering. Okay. So let's consider next example. Here, so what can extract? What feature can we extract? Maybe so if we draw this dotted line, so we may extract the feature of shape. So circle, star, or lozenges like this. Here. Okay, I already explained. Okay, what feature can you perceive from the segmentation? Okay, how about this? What feature extract? What feature do you extract? Maybe color. So how about this? On color. So green color and so blue colors. So in this case, so we classify the small difference between green and so light green, so light blue and normal blue. On the other hand here, so we can abstract. We can so categorize these two are green and these two are blue only. So this is our human cognitive ability. So anyway, so here, so we can manifest, we can clarify the meaning of clusters by segmentation. So if we conduct segmentation like this, we can extract its corresponding features very clearly. So this is a aim of clustering. In order to reveal some features, we have to conduct clustering. Actually, so you can deal with large scale of medical data. So if you try to change the clustering method, or you can change the boundary, so you may extract new different features. So therefore, clustering is very important. So here, so we can manifest the different meaning of clusters by changing the boundary. So if we change the boundary, so we can clarify different types or different level of features. Here, so this is a summary. So we need the relationship, structure of difference. So here is the most important. So which kind of feature? So difference. So we need the structure of difference. Without difference, we cannot classify. We cannot conduct clustering. Okay. So according to the difference, according to the structure of difference, we can do such a thing. So here we need the boundary. Boundary means structure of segmentation to manifest the relationship. So these two approach are coupling. So we refer to individual approach each other. So nesting each other. So in maybe next week I will explain how to conduct clustering. In case of clustering, we first make a segmentation, and then we try to extract some features, and then according to the features, we change the boundary. So we repeat. So these two approach. So in this way, we can find some meaning from the data distribution. So this is the essence of cluster analysis. Of course, so you can learn how to conduct clustering. So at the YouTube movies on clustering method, it is easy for you to understand how to conduct the clustering. But so they just show the tool of clustering. They don't teach the importance of clustering. Okay, so according to human cognitive ability, we can discuss such kind of high level of human intelligence by using cluster analysis. Okay, so next one, please. So I have 3 minutes here. Okay, so I just explained the methodology by using simple mathematics. So here we obtain some data. So given data is x and y. So this is a coordinate. And also we can recognize the color of RGB, red, green, blue, or something. So here, in case of clustering, so we just use all of given data, X, Y, RGB, and then we try to find suitable boundaries. So this is output. On the other hand, in case of classification, so we know how to divide. Therefore, the input is, for example, X and Y. And so here in this example, the output is RGB. So if you want to classify the color, the data from the viewpoint of color, so this is a difference so between clustering and classification. So finally, so I will explain some small classification problem. So this is an example of linear separation. So here there is a point of red point and blue point. We can divide these data by using one line here. So here by using the coordinate system, so we may write some equations. For example, in this case, if we classify this data as a red, we can use this inequality. So x2 plus x1 is larger than 2. Actually, so larger and equal, sometimes it's okay. Yeah. So how about this? So we can use two lines here. So x2 plus x1 is larger than 2, and x2 minus x1 is larger than minus 1. So in this way, so we can classify these data in red or blue. This is very simple linear separation. So now I explain. So in our brain, what did I do? So for example here, so we can use two inequalities like this here. So by using the inference, for example, like this, so I explain so this problem into two steps. So first one is this: if x2 and x2 plus x1 is larger than 2, then y1 is 1. Okay, so we use internal parameter like here, Okay, and then so if x2 minus x1 is larger than minus 1, then y2 is 1. This is the first step. Okay, and then so this is an addition of two overlapping area of these two regions. Then so if y1 plus y2 is equal to 2, then red. Okay, this is my inference pattern. This is very simple. So we can use this kind of inference into network representation. The input is x1 and x2. This is internal parameter of y1 and y2, and output is red or blue. So in case of 1 is red. In case of 0, then blue or something. Okay, so next week I will explain neural network. Actually, in case of deep learning method, so we can use many layers, internal layers, and then so we can realize high level of classification. Anyway, in this way, so by using our knowledge, so we can represent some knowledge like inference if-then rule. And also we can represent this inference mechanism into by using network representation like this. So now, I will summarize my talk. So here, next week I will explain the methodology of clustering and classification. Here, why? Artificial intelligence is very important in this kind of discussion. So now, I will discuss the current role of artificial intelligence. I already explained what is sensing. Okay, so this is this is how to define the search space. So now, we can use very huge size of data. So IOE, you know, Internet of everything. Actually, so if we define IOE, we can never define new word of Internet of so anyway, so here, so IOE is composed of IoT, Internet of Things, IOH, Internet of Human, and also IOD, Internet of Digital or Data. So this is a definition of IOE, so everything. So here in the physical world, so we can measure environmental data by using IoT. We can measure human biosignal or human data by using IoT. And also by using IoD, so we can send the huge data and receive the data. Okay. Okay, now, so here, yes. So we receive, so human, we can have many human data and environmental data and social media. So, you know, so if we stop using social networking service, information exploration will never occur. Okay, so human behavior make our world information exploration. It's a problem. Okay, anyway, so we can use huge size of data by using machine learning. I will explain as machine learning next week. So by using machine learning or something, we can extract some features, and then so we can generate new data. So here, maybe you know digital twin. So this is also very interesting keyword. If you are interested in digital twin, so please check this keyword. So today I explain the concept of clustering and classification. This is a subcategory of machine learning. Okay, so this shows the hierarchy of AI. So this is a traditional approach of AI. So we can use several methodology. So I will explain some method in the next week. So here, so according to the this method, so we can extract some features, new features, unknown features from big data. So this kind of approach is called data mining. So after 2029, so deep learning methodology was very popular. And then, so by integrating computer science and data mining, so data science, the research field of data science was built. Originally, data science, the keyword of data science was used in 1965, but so in these days, we often use the keyword of data science. Okay, so and also we may sometimes use data analytics. So data science and data analytics is very similar concept, but something different because so the keywords are different. Okay, so this is a difference. So I don't have time, therefore I skip. I'm sorry. So anyway, so clustering and classification is the most important tools in data science and data analytics. Okay, I show something. Okay, summary. So today, so I discuss human ability of problem solving, and then so we discuss the clustering and classification. So next week, so I will explain the essence of the clustering from the mathematical point of view. Maybe so most of you are graduate students, therefore, so next week talk will be interesting to you, I hope. Okay, I just show one example. What is this? What is this?
Yeah.
So maybe, so Apple, right?
Yeah.
Yeah. Nobody reply. This looks leaves or something. Maybe so you explain, you reply. So this is apple. You don't say this is fruit. Of course, this is also correct. But you reply, this is apple. Why? Why don't you say this is fruit? Why don't you say this is leaves? Oh, this is the essence of visual perception. We will discuss about this matter. Thank you very much.
Thank you, Prof Naoyuki. That was the presentations of Professor Nao, and now we're going to the next sessions. This is discussions. This session is, sorry, Prof Naoyuki, there are a lot of questions. I send you privately in Zoom chat. Can you see it? There are 10 questions, but you only have times until 10, I think. So,
okay, so I will reply some question. Okay, so this is interesting question. So how is intelligence application for maternal and child health? For example, so actually, so last year, so we conducted experiment to children with developmental disorders. So they, such as a child, don't talk to other child so much. So when we use robot partner for the chat with such a child, so they try to teach something to robot. So actually, so until that, so children keep silent. But so when they can enjoy some communication with robot, they try to teach something to robot. So this was very amazing. So findings. So anyway, at that time, for example, so if a child show have to deal with toys, so and then the robot try to imitate such kind of play. At that time, the child can wait so until the robot finish such kind of play. So this means children can learn turn-taking behavior. Yeah. So this was very interesting finding from last year's experiment. So this is one example. So in this way, so according to the intelligent methodology, so we can train children with developmental disorders. So this is one example. Actually, so I don't have enough time to explain the detail. So the next, yeah.
Sorry.
So next, yeah.
Okay, so it means that, is it possible if we apply the artificial intelligence in the hospital, especially in nursing and midwifery practice, right?
Yeah.
Yeah. So it is possible to apply the artificial intelligence in the nursing and midwifery practice in the hospital, especially this COVID-19, in pandemic era. I think, is it possible, Professor? What do you think?
Actually, so this is a big question, therefore it is very difficult, but so this is a point. So next week I will explain some clustering and classification method. So for example, in case of personal analysis, so we can classify some patient pattern into several categories, and then so we can find some interaction or recommendation methods separately. So if big data available, so we may find new important features. It's okay?
Okay.
Yeah.
Okay. I think time is up. Thank you for all the questions. And I will let you know that there are 100 participants in YouTube channel right now. Yeah. And finally, we come to the last sessions of this virtual lecture. Thank you to Professor Nao for a new science here. And also thank you to all audiences for your participation. And hopefully the information that we have shared today will be useful for all of us. Thank you and see you on the next virtual lecture series. And we hope Professor Naoyuki can to be a keynote speaker at the International Seminar of Poltekkes Kemenkes Semarang at the beginning of August, I hope. Okay, thank you, Professor Naoyuki. Right now, I give the time for Mrs. Novita. Thank you.
Terima kasih.
Terima kasih.
Okay. Thank you very much. Thank you very much for the speaker, also the moderator for informative and insightful presentation. Ladies and gentlemen.
Yeah. Okay, so I try to finish sharing. Okay. Yeah.
Question and answer.
We already have
question and answer.
Mbak Novita, we already.
Yes.
Yes.
Okay, thank you very much for the speaker, also the moderator for informative and insightful presentation. And ladies and gentlemen, those are the agendas we have presented to you this morning as we have finished our event. May today's virtual lecture activities be beneficial to all participants. And as the host, we apologize for any shortcomings in our behavior and speech. So see you next time. And good afternoon. Have a nice day. Thank you. Arigatou gozaimasu.
Terima kasih.
Terima kasih, Professor. Thank you.
Yeah.
See you next week.
Yeah, thank you very much. So actually, I received similar questions from the chat in Zoom. I prepared the reply to their questions until the next week's seminar. Okay.
Okay.
Thank you very much. Very interesting. So question. Okay. Thank you very much.
Thank you.
You're welcome. Thank you. Thank you.
Okay. See you next week.
See you next week. Thank you.
Bye bye.
Bye bye. Dr. Nia, thank you.
Yes. Bye bye.
Bye bye. You look so beautiful.
Thank you. Okay.
Yeah. Bye. See you tomorrow, Dr. Nia. Oh, see you live. Okay. Terima kasih, Mbak Novita.
Pak, sami-sami.
Oke, saya izin keluar ya.
Ridi.
Sebentar, masih menunggu untuk sertifikat.
Oke. Pi ngomong Pi. Masih apa? Mohon untuk para peserta, link sertifikat akan kami kirim. Kami masih menunggu proses untuk dikirim di akhir. Mohon ditunggu. Mohon perhatian, silahkan untuk mengisi daftar hadir, spare waktunya hanya 10 menit, dimulai dari sekarang.